Here is an introduction to scientific notation. Scientific notation is a way to write a very long number in a compact form. So let me give you a long number. So starting with so let's say for example, we have 356. Let's make this really long by adding zeros. So let's add how many? I'm going to add 9 zeros. Okay, so when you write a long number, you put a comma between every 3 digits. So 3 digits, 3 digits, 3 digits, right? So this is the way I say this number is, or read this number is 356 followed by 90. So for scientific notation, the first step is you have to give me a number that is between 1 and 10. Between 1 and 10. It can be 1. So I will be using 3.56. Can I use 0.356? No, it is not between 1 and 10. How about 35.6? No, not between 1 and 10. How about 356? No, also not between 1 and 10. So 3.56 is the only option. And then you multiply, this is always a multiply, always a base 10, and then raised to some digits right here, raised to an exponent. So what exponent goes up there? So here is how I do the counting. So I am going to put a decimal point right here, so 3.56, and then I will move the decimal point to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I am going to say 11 steps. So since that is 11 steps, and then I will just erase this line and then say that this is times 10 to the 11 power. So basically this is a 3.56 multiply 1 followed by 11 0. So that means starting at 3.56, you move the decimal point 11 steps to the right to get to these long numbers. Starting at 3.56, you move the decimal point 11 steps to the right. Let's draw a description. So that means at 3.56, move the decimals. So when you go back to review your notes, you know exactly what you did, right? Move the decimals 11 steps to the right. All right. So let's do another example. So this is a very large value, right? Let's do a very small values. So let's say I'm counting the 0 for my notes. So let's say negative. So another example. So let's say negative 0. How many zeros did I use? 1, 2, 3, 4, 5. I'm looking at my notes right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 0. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 12 0. And then 3, 1, 4. So this is a very long number. The value is very, very small. And then my question is, what number goes up first? Can I use 314? Oh, by the way, I forgot the negative, right? Can I do negative 314? Is this between, don't worry about the negative. Is 314 between 1 and 10? No, right? How about 31.4? No. How about 3.14? Yes, 3.14. Disregard the negative. That is between 1 and 10. And then times 10 to the what power? Okay, so I'm going to, let me change this to a different color. Let me use this color this time. So at 3.14, so let's say this number doesn't exist. At 3.14, how do you reach to this number? Then you have to move the decimal point to the left. Okay, let's do the move. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that is 13 steps. So 13 steps. And then this will be a negative 13. A negative 13. So we are moving the decimal point to the left. So this is move the decimal point. 13 steps to the left. 13 steps to the left. All right. Okay, let me give you another one. So let's do something easier. Let me switch to a different color. Let's do green. So how about what if I give you 4.85, this is between 1 and 10, right, times 10 to the fifth power. So the way I do this is, so this one times 10 to the fifth power, that is the same thing as 4.85 times 10, 1 times 1, followed by 5 zeros. The way I do the counting is, I do 4.85, no, 485. You can do this as a draft, and then I just add a few zeros at the end, because I'm going to do some erasing. So starting at 4.885, right? How many steps do you have to move? Oh, you know what? Let's get rid of the equal, because this is my draft, scratch work. 4.85, so 1, 2, 3, 4, 5. And then you start right here. So that is equals to 485, and then followed by 30. So this piece is basically a scratch work. Let's try one more. Let's try a negative, shall we? Let's say negative 1.38 times 10 to the negative 4. How's that? So this will be, what is 10 to the negative 4? Do you remember that like a to the negative n is equals to 1 over a to the n? So let's say 5 to the negative 6 power, that is 1 over 5 to the 6, right? So this is negative 1.38 times 1 over 10 to the 4th power, which is negative 1.38 times 1 over 1 followed by 4 zeros. Am I right? So that is negative 1.38 divided by 1 followed by 4 zeros. So the way I do this is, I will do the negative at the end. I will do 0.38, because when you divide it by a large number like that, you are moving the decimal point to the left. You are making the number smaller, right? I will just add some zeros for my scratch work, and then I will do the move. Here is how I do it. 5 steps. So 1, 2, 3, 4, 5. 5 steps. 5 steps. Oh, 4. Huh. I was doing this wrong the whole time. Okay, hold on. Everyone is right. I am doing this wrong. Okay, let's go back. Negative 4. 4, right? 1 followed by 4 zeros. 1 followed by 4 zeros. And then should be 1, 2, 3, 4. 4 steps. 4 steps. And then remember, this is a scratch work, so that is equals to 0 point. The decimal point is like right here. So 0.000138. That is your answer. All right, so let's do a general form of scientific notation. So scientific notation in general. So let's write scientific notation. So in general, this is a times 10 raised to the nth power. And then the absolute value of a, because we have to disregard the negative, is between 1 can be equal to 1, but cannot be equal to 10. So between 1 and 10, disregard the negative, between 1 and 10, and then it can be equal to 1, but it cannot be equal to 10. So I'm going to go back to check my work real quick. So this, disregard the negative. Let me pick up my highlighter. Disregard the negative, right? Between 1 and 10, disregard the negative, between 1 and 10. What else? Disregard the negative, between 1 and 10, and then disregard the negative, between 1 and 10. So that is a scientific notation. So this one, if you do a 35.6, that is wrong, because it is not between 1 and 10. So for example, A can be, let's draw some example, like negative 3.14, 3.14, 9.20, 4.37, 2.01, or you can do a 2.0000001, and then negative 1.98, negative 2.1, 3.5, 7.2, 9.9, or 9.0009. You can play negative 9.9, something like that. How many digits should you use? I usually use 2 decimal places, usually when I write scientific notation. So I usually do like 3.56 times 10 to the negative 5 or something. Like if you really have to keep 2 decimal places, you can do a 3.60 times 10 to the negative 5, like keeping 2 decimal places. 2 decimal places means you are keeping 2 digits on the right hand side of the decimal. And then what about the very long value? The very long value is not a value, it's a number. So this very long number, this is called a standard notation. So let me give you another example and then I will finish this video. So for a standard notation versus scientific notation. So standard notation, so let's say you have a long number like that, 73, followed by 5 zeros. Okay, followed by 5 zeros. And then for scientific, you have 7.3 between 1 and 10 times 10 to the what power. So let me grab my highlighter. This is times 10 to the, starting at 7.3, 1, 2, 3, 4, 5, 6. So that is 6 steps. And then this is to the 6th power. Alright, so that is the standard notation, a very long value, versus scientific notation, a very compact form. And then regarding switch back and forth between scientific and standards, all the notes are explained and written right there. Alright, so that is the end of this video. In the next video, let's do some example regarding converting back and forth from standard to scientific and from scientific to standard, right? I will see you all in that video.